In this video, we will learn about the basics of vectors. So let's start with the definition of a vector. That what is a vector? So vector could be called as an array of ordered number, or in another way, vector can be called column matrices. We know about matrices, right? We know about matrices. Now vector are column matrices. So column matrix. So a column matrix is equals to vector. So the example is that this is a vector whose values are 3 and 5. This is a vector, and vector usually represented with small letters like V and an arrow sign over them. Sometimes we don't use arrow sign, we use the bold letters, but usually small letters with an arrow sign above them. So this is a vector, and let's make another vector W. This is vector W. Its name is W, and it's a column matrix. That means column matrix means that we know that it has 2 rows but 1 column. So this has 2 rows and 1 column. Similarly, this will have 3 rows and 1 column. So it is a column matrix. So in this case, we will have 0, 2 and 7. And this is also a vector with 3 rows and 1 column, right? So these are the definitions, these are the examples of vectors. So I hope that you will be able to understand what are the vectors. They are just column matrices and their order matters. Order means like if we have 5 here and 3 here, that will be a different vector, not the same vector, right? So order of the numbers matters. So the second definition we have to do is dimensions. Vectors dimensions. So dimensions. Dimensions are the number of elements in the vector. So the vector V dimensions is, so maybe I can write dimensions of vector V is equals to 2, because it has 2 elements in it, 1, 2. Similarly, dimension of vector W is 3, because it has 3 elements in it. So dimension of vector W is 3, because it has 3 elements in it, 1, 2 and 3. Make sense? Similarly, we could have a vector of n dimension, where it has a dimension of 5 or 6, n could be any number, right? Maybe we have vector dimension of vector Z is equals to 3 million. So maybe it's I think I have written 300,000, but it should be 3 million, so I need 1 more 0. Yeah. So 1 more 0. So 3 million, right? So vector of dimensions, the dimension of vector Z is 3 million. Make sense? There are different kinds of operations on vectors, and one such operation is dot product. So assume that I have 2 vectors of same dimensions. Dot product will only work if vectors are of same dimensions. So let's say I have vector V and I have vector W, and vector W has to be also 2 dimension, because it is a 2 dimension vectors, and I need another 2 dimension vectors to find dot product. So let's say it is 1 and 7, and I have to find dot product, which is also known as inner product between these 2 vectors. So I have to find dot product, aka inner product.
Dot product?
Yeah, dot product or inner product. It's like a product is multiplication, so it's like a dot multiplication or inner multiplication, right? So I have to find the between vector V and vector W, and usually sometimes we write these dot product with this notation. This is a very good notation, but in the basic books we don't see this notation, but this is a very good notation. In the quantum books you can find this notation, in the quantum mechanics books, but just remember this notation at that for the time being. And this means the dot product will be equals to transpose of the first vector times second vector. So that's the dot product. Now let's find the dot product with, in our example, is going to be transpose of the first vector. What the transpose is, in the matrix we have found transpose where we convert column to rows and rows to column. So for this vector we have to find transpose. That means rows will be column and column will be rows. So the first row will be, the first column will be first row.
Can
Yes.
we find transpose of W?
No, the formula says transpose of the first vector times second vector.
Will it change anything?
So dot product is not always commutative. Means we can't change them. We can't switch their order. The dot product is commutative for the real numbers, but not for the complex numbers. For the real numbers, we can switch their order. For the real number, dot product of V and W is equals to dot product of W and V. So I have not yet explained that what are the complex numbers. So for the time being, this is not always equals to each other. This is only equal for the real numbers, right? So stick with this formula, that transpose of the first vector times second vector. Make sense?
Yes.
Don't change the order at the moment. So the first vector transpose will be 3 and 5, because the column become row, right? And the second vector will be as it is, which will be 1 and 7. Now this vector dimension is that it has one row and two columns, and this vector dimension is that it has two row and one column. And when we multiply two matrices, because vectors are also matrices with a single row or single column, then our result going to have one row and one column. Remember, our result going to have one row and one column. And when we have a vector or a matrix with one row and one column, it is called a number, right? So the answer of this operation will be a number or a scalar. We also call a number a scalar. So now let's multiply. So 3 times 1, this is a matrix multiplication, that first row with first column. So this and this. So 3 times 1, 3 times 1, which is 3 obviously, and 5 plus 5 times 7. 5 times 7. And because it has only one row, one column, so that will be it. That is it, right? And I am writing at the moment this sign, but I will later on will not write this sign, because when we have only one number in a matrix, it is just a number. We don't say it's a matrix. So it's going to be 3 times 1 is 3, is going to be 3 plus
35
plus 35, and it's going to be 38. And I have stopped writing brackets here because it's just a one number. So now we know what the dot product is. Similarly, so we know so far we know the following. We know that number one, that what is a vector, right? We say vector is a column matrix, right? And order matters. Even in a matrix, order matters. Second thing we know is that how to find transpose of a vector, right? We know how to find transpose of a vector. Third thing is that we know how to find dot product of a vector, right? How to find dot product. Yes.
The dot product always has to be the column matrix set.
Yeah, dot product is for the vectors, right? So dot product answer is a scalar. What's the answer? Dot product is a scalar or a number. Scalar is basically a number, right? So far we know these things. But number 4, we want to know that how to find length of a vector. We have a vector, we want to know what's the length of the vector. So we want to know length of a vector. And number 5th, we want to know that we have two vectors that have the same origin, that means that start from the same point, and we want to know that what's the angle between those vectors. So number 5th, we want to find angle between two vectors, right? So now let's start. We are done so far with this, this and this, and these are the two things that we want to do more. So length of a vector. So let's say I have to find length of vector v. And length of a vector is sometimes you can write it equals to v and these two bars. That means we have to find length of vector v. Make sense? And the formula of length of vector v is equals to that you find dot product of v with v and take square root of the answer. That's the formula of finding length. So you take dot product of v with v and then the answer you take the square root. Let's do an example and make it clear with an example. So in this example we have a vector v which is let's say make it 3-dimensional, because dot product we can also find dot product 3-dimensional stuff, right, or 4-dimensional. So let's say this is a vector v which is 3-dimensional vector. We have here 1, we have here 2 and we have here 3, right, and we have to find length of vector v, right. So we have to find length of vector v. We say the length of vector v will be equals to dot product of v with v and a square root, and that will be equals to what? Dot product of v with v. Let's say for the time being we will do square root at the end. First we find dot product of v and v. So we take transpose of the first and multiply with the other, and because both vectors are v, so we take the v transpose and multiply with it. So basically we take v transpose and we multiply it with v, right, and then answer will take square root. So it's going to be what? It's going to be v transpose is going to be 1, 2 and 3 and v going to be 1, 2 and 3, and whatever answer we have to take a square root, right. So now we multiply 1 with 1, answer is going to be 1. I'm not writing 1 times 1, okay, because it's easy. So I have to take a square root of 1 times 1 is 1. I'm not even writing these brackets because I know my answer will be a number, right. So 1 times 1 is 1, 2 times 2 is 4 and 3 times 3 is 9. So it's going to be square root of 5 plus 9 is 14. That's the length of this vector. Make sense?
Yes.
Any questions? So we can find similarly length of any vector using this formula, and I will give you some exercises to remember it by heart, right. So now you know how to find length of some vectors. The last thing that we have to cover is how to find angle between two vectors. So let's find angle between two vectors. We can find angle between two vectors using this formula. Let's say you have vector v and vector w. Then there is formula which says that cos theta is equals to dot product of v and w. So yeah, I've written dot product previously like this notation, which is a bracket notation, but this notation is not used in the books. So there's simple notation used in the books, in the beginning books basically, which is v dot w. So this is also dot product notation. These notations are same, and this what's the result of this thing is that take transpose of the first vector times the second vector. So transpose of the first vector times second vector. That's our answer. So now we are writing dot product of v and W divided by length of V times length of W. That's my formula, and I can use this formula to find angle between those two vectors. Angle is theta, so I have to say basically theta is equals to cos inverse. When I take cos here, it becomes cos inverse. So cos inverse, and inside I have V W and divided by, and our calculator guy will help us to find cos inverse when we ask him, because in the calculator we have cos inverse function. So that's it. So now let's do an example to make this clear that how we can find angle. So in this example, my let's say my V is equals to 2, 2. By the I'm just writing vectors like this, and this is another notation to write vectors. Basically this notation means that this is the first element of my vector, this is the second element of my vector. This notation is equivalent to this notation, 2 and 2. So these two notations are equivalent. When you write vector like this, you have to put a comma in between them. Otherwise, it looks like it's transpose of a vector. It's not a transpose of a vector.
Can we just write it in normal way? It's
Because we have to know this notation, because many times people use this notation. So
we can know it, but we should not use it.
No, because if you have to read any book, you will find this notation. If you don't know this notation, you will get confused. So you should know this notation also, right? So vector V is this, and vector W is 0, 3 in this notation, and that means it is equals to what? 0 and 3. And remember comma here, it's not transpose, it's the same thing written differently, right? So now we have to find angle between vector V and W. We have to find angle between V and W. So what we use this formula. Let's say first find dot product, then find V length, then find W length, then use this formula. So dot product of V and W will be equals to transpose of V, which is equals to 2 and 2. Now this thing is not this, because we have taken transpose, right? This thing is different. There is no comma here, and times this. So it's going to be 0 and 3. And answer is going to be yes.
Like we have that 2, 2, like in the matrix, and we had that other one like this. Can we make that into a comma thing? Something?
This thing in a comma?
Yeah, comma form.
So in the comma form, this will be can be written like this: 2, 2, and then a transpose sign above it, right? So you have to write. You can write it in comma form, but you have to put transpose sign above it,
Okay.
right? Because if you don't put transpose, then it means it's a column vector. And if you put transpose, then it means a row vector, right? This is a kind of a row vector. So now we have this thing, and if 2 times 0 is going to be 2 times 0 is going to be 0, but it's very difficult. Plus 2 times 3 is going to be 6. So it's going to be 0 plus 6, and that's my answer of this thing. So I remove this thing, and I write here what?
6.
So I remove this thing. I have my answer, and I write here 6. Now I have to find this one, right? So I have to find length of vector V. Now I'm going to tell you a shortcut method of finding length, which is used many times in a book, but the thing is the shortcut method will not work always. It will work if the values are real somehow, right? Otherwise it will not work.
How can you check if it is?
So if the value has no iotas, iota is an imaginary number, then you can use the shortcut method. So let's say I have to find length of V. Then I can say length of V is equals to square root of V transpose dot V, right? And then I can find V transpose and etc, etc, etc. But what I can do, the shortcut method says that the length of V is, if V has a real numbers, then it's equals to square of the first plus square of the second. So it's going to be square of the first plus square of the second, right, with the shortcut method. And you can see that these two are equivalent, because if I take, let's say, transpose of V, I will get 2, if I then multiply it with this 2, then my answer will like 2 times 2 is this one plus 2 times 2 is this one.
Yes.
So this is a shortcut method, that's square of the first plus square of the second, and then the whole
Does this work
square
with
root.
3 elements?
It works with 3 elements, it works with 4 elements, always work as long as elements are real. If elements are not real, then don't use that, right?
I don't get what real means.
So
If it's a type of number you studied till now, it's real.
it's real, right? It doesn't have some iotas in it. We don't know.
Iota?
We don't know
Special
that.
character.
It's a special. We will know about it iota later on. So then the answer is going to be what? Is going to be 4 plus 4 is equal to square root of 8. So that's my answer. So here I can put what?
8.
Square root of 8. Not 8, but square root of 8. Or I can also put, because 4 can come out. It's like it is like this. It is like 2 times 2 times 2. And in the square root, anything which is twice can come out. So these 2 can come out once. So I can write here 2 and 2, which is 8. Because when we go inside, it becomes 4. So 4 times 2 is 8. So this is my 1. Now I have to find W, length of vector W, and I will use shortcut method now. I don't want to waste my time, right? We know.
Yes, please.
So the W, length of W is going to be square root of 0 square plus 3 square. 0 square plus 3 square is going to be 9. And 9 I can take out from the square root immediately, because 9 is 3 times 3. And because there are 2, 3, then there will be no square root. My answer is going to be 3. Right? Because 2, 3, then they will come out, and when they come out, my answer is going to be 3. So
Can
that's,
there be the square root of the 0?
there could be, why not? So now my answer is going to be 3 here. Now I have to simplify this, then because 2 times 3 is what? 6, because they are multiplying. So above we also have a 6. So that means after simplification, what I will get theta is equals to cos inverse, and because this and this and this will cut from each other, so I will get 1 over square root of 2. And now our calculator guy will tell us that what's the answer is going to be.
1 second.
So we are in a waiting mode because our calculator guy is,
45.
so answer is 45 degrees. So that means angle between these two vectors is 45 degrees. But what that means, that angle between these two vectors, graphically.
I was just going to ask that.
So graphically what that means, that angle between them is 45. So now in the next video we draw vectors and we see those angles physically happening. So now let's do the next video.